Hello, this is Mr. Gilmore with the 2.3 proof setup lesson. We are going to begin in this chapter to look at what a proof is. And in order to look at a proof, we need to learn how to properly set up a proof before we actually jump into any of the logical statements that we're going to be making about it. Now, it'd be a good idea to start with the definition of what a proof is. So, really, a proof is a sequence of statements. We're not just going to see facts being listed, but it's going to actually be a list of connected facts that are going to follow in the sequence of statements. This sequence of statements is going to take us from the given of our proof to the conclusion of our proof. Now, each of these statements that we'll make, we have to justify each of the movements we make, each of the connected facts we make, which means we're going to justify them either by using a definition, a postulate, or a previously proven theorem. And that's going to take us from one step to the next. We cannot take a step without justifying each one of our steps. Now, the most common way of setting up a proof is these three steps. So, step one, we're going to take the theorem and make sure it's written in conditional form, meaning the if given, comma, then conclusion form. So, the if then is the condition we're looking for. Step two, typically draw and label a diagram. Now, I say typically because there are just a handful of proofs in which you do not need to draw a diagram, but most of the theorems we encounter will have a diagram for it. And then number three, write a given statement, and then on a new line, a prove statement. Now, this given and this prove statement are going to be specific statements that we're going to pull from the diagram. We're actually going to be referencing the figure, the diagram we've drawn, and helping the reader, such as ourselves, even someone who else is reading our proof, to use the diagram as a reference. But we got to make the given and proof statement specific. It won't be just the generic given that we find in our conditional, and it's not just going to be the generic conclusion. It'll be something specific related to the diagram. So let's look at step one at further detail. So step one, remember, we're going to write our given our given statement into a conditional form, the if then. So let's say I ask you to prove that vertical angles are equal in measure. So what you would say in conditional form, if two angles are vertical, then they are equal. So it's just simply taking our given prove statement and turning it into our conditional form. Step two is the diagram. Now, the diagram will be important when needed. Again, I mentioned earlier that not all theorems will require a diagram. That's only a handful, though. Most of the theorems we prove will need a diagram. Now, the diagram must be labeled. We must be able to give the reader something to observe. So, we're referring to a segment or referring to an angle. They must be labeled in such a way that we can refer to those. So, for example, with our original conditional we looked at on the previous slide, if two angles are vertical, then they are equal, we need to label the diagram with the vertical angles so we can refer to those vertical angles. Step three, this is going to be where we learn over time of looking at what does the given statement and the proof statement need to be. These, again, have to be specifically related to the diagram that you drew, which means if you're drawing a diagram with, let's say, angle names and segment names, you need to refer to those segment names and angle names in the given and prove statement. So make sure that your object, the diagram that you are referring to, is labeled enough that you can generate a given and prove statement. Let's see this come to life in an example. So again, I'm going to go back to the statement, prove that vertical angles are equal. Now we already wrote that in conditional form, so I'm going to skip that step. The conditional step would be if two angles are vertical, then they are equal. But now our step two is to draw a diagram. Well, I need to draw a diagram of the given. I need to draw two vertical angles. Well, the definition of vertical angles states that there are two angles in which their sides form two lines. So here is a start of my diagram. I've got two angles in which their sides form two lines, but I need to label a pair of vertical angles. So I'm going to choose these two as my vertical angles. I had another pair I could have picked, but I'm going to refer to this pair of vertical angles. So angle 1 and angle 2 are my vertical angles. That's step 2. I can actually refer to the diagram that has my pair of vertical angles in it. But now on to step 3. I've got to make two statements, one for the given and one for what I want to prove. But those statements must be specific to the diagram. No, I cannot use just a generic blanket statement for the given and prove. It must be in reference to what we drew. So the given is the first part of our conditional. If two angles are vertical. Well, I have two angles I can reference. So for my given, I can write angle 1 and angle 2 are vertical. That's the given statement of my conditional, but it's been made specific to the diagram. Now my reader can look at the diagram and go, oh, there's angle 1 and angle 2, and yes, they see them as vertical. Now for the proof statement. The proof statement is really the conclusion of our conditional. The conclusion is that I want to prove the angles are equal. Well, I'm going to make that statement specific now again to my diagram. So what is it that I want to prove? I want to prove that the measure of angle 1 is equal to the measure of angle 2. And now, again, I've made that specific to my diagram. So this would be how I would set up that proof. Next step, which we're not to yet, would actually be giving the proof of this. Now, we're not there yet. All we're going to do is practice just setting up because the setup is important. It gives the reader the starting point and the ending point to our justifications and to our proof. Let's do this one more time with one more example. Prove that the sum of the angles of a triangle is 180 degrees. Now, I'm not going to write out the conditional, but if I were, it would say something like this. If a polygon is a triangle, then the sum of its angles is 180 degrees. So the given, right, is some triangle, and the conclusion then is that I'm proving the sum of its angles is 180 degrees. Now I need a diagram. Well, what am I given? I'm given simply a triangle. So my diagram is just going to look like an average ordinary Joe triangle. There you are. All right. Hello, triangle. But I need to be able to reference this triangle, which means I'm going to have to name it. So at each one of these vertices, I'm going to give a name to that point. So now I have triangle ABC. Well, again, once I've got my diagram, I need to make my given and prove statements specific to that diagram. So what am I given? I am just given an average ordinary triangle, and we have a name for it. We're given triangle ABC. Okay, so there's our given. I've made it specific to the diagram. What would the prove statement be? Well, think about the conclusion of our conditional. The sum of its angles is 180 degrees. I need to then transform that general statement into a specific one that references the diagram. So I could say the measure of angle A plus the measure of angle B plus the measure of angle C is equal to 180 degrees. Now, my diagram must only reflect the given. It cannot reflect the conclusion yet. That's the conclusion we're going to reach through our proof. And again, the next step after this would be to start the proof, starting at the given and working with connecting logical statements together to get to the proof statement. That is the end of our 2.3 lesson on proof setup. Be sure to check out the worksheet for more information and be working on that homework assignment. If you do have any questions, please do not hesitate to email me. With that, be good and do good.